Assalamualaikum warahmatullahi wabarakatuh, and hello there, everyone. I hope that all of you are doing great out there. And first and foremost, let me introduce myself. My name is Ahmad Amiru Berozali. So, today, me and my friends will gonna explaining to you about the application of differentiation about the related rates problem, and then we also gonna show you an example of a real life problems that require a related rates method to solve it. Without any further ado, let's start it off with the introduction by Amirul Hakim. So let's go.
The definition of derivative. The derivative is defined as something which is based on some other thing. In mathematics, derivative is an expression that gives the rate of change of a function with respect to an independent variable. Derivatives have various applications in science, mathematics, and engineering. Some topic that we will learn in this application is rate of change of quantity, approximation, maximum and minimum, and many more. That is the meaning of derivative.
So that is a short and simple explanation from Amirul Hakim about the application of differentiation in related rates. So next, let's move on to the objective of the related rates from Hadi Nasuha.
Okay, Assalamualaikum. My name is Muhammad Adi Nasuha bin Malaki. Today I'm gonna talk about the objective of related rates. The first objective is to find the rate of change from one quantity, knowing the rate of change to another quantity. The next one is to find an unknown rate of change by relating it to other variable whose value or whose rate of change at time are known or it can be found. The last one is finding the rate of change of two or more related variables that are changing with respect to time.
So I hope that by understand the objective of the related rates, it will be easier for you to apply the concept in the real life problem, which is this is what we're gonna do next. So let's move on to the example of a real life problems that require related rates method to solve them. Okay, so the problem statement is a bag is tied to the top of a 5-meter ladder resting against the vertical wall. Suppose the ladder begins sliding down the wall in such way that the foot of the ladder is moving away from the wall. How fast is the bag descending at the instant the foot of the ladder is 4 meters from the wall, and the foot is moving away at the rate of 2 meters per second. So that is the situations that require related rates method to solve them. So to see how do we solve these problems, let's move on to Falik to see the calculation method.
So to get the answer for this question, we first need to know information about it. So first we know that the resting ladder will be in the shape of triangle, and the length of the ladder is 5 meters. We also know that the foot of the ladder is 4 meters away from the wall, and we also know that the rate for the foot moving away from the wall is 2 meters per second, and we still don't know the height of the bag on the ladder. So first we need to list down every information that we have. So first, for the hypotenuse, which we call as C, will be 5, and we also know the x, which is 4. We still don't know the y, and we also know the rate, which is dx dt equal to 2. So since it's a triangular with a hypotenuse, we can use the formula of x squared plus y squared equal to c squared. And we need to search for the y first. So we already have x, which is 4 squared equals 16 plus y squared equal to c squared 25, and we just need to move it. Y squared equal to 25 minus 16 and square root of 9, and we get 3. So the y is 3. So to search the rate of the bag dropping to the floor, we could use the same formula again. So to do that, we just need to differentiate it with the respect of t, and we can search for it. So x, it will be 2x dx dt plus 2y dy dt equal to 0. Since c squared is 25 and is constant, it will be 0 after differentiation. So the one that we need is the dy dt. So for the other variables, we already have the information and we just need to put it in. So it will be 2x, x is 4, dx dt, we also have that, which is 2, plus 2y, which is 3, dy dt equal to 0. So we just need to move the information from the left side to the right side. So it will be 6 dy dt equal to minus 60, and we move the 6 and it will be minus 16 over 6, and we just round it up and it will be minus 8 over 3, and that's the final answer for this question.
So that is how we solve the related rates problems. And next, before we end our video today, I would like to give you some strategies to solve related rates problem. So the first one is read the problem carefully so you won't miss any important things that we need to answer the questions. And second, draw a diagram so you have better understanding. And 3, introduce notations, give symbol to all the quantities that are functions of time or maybe some constant. 4th, express the given information and the required rate in a term of derivative. And 5, write an equation that relates the various quantities of the problems. If necessary, use geometry of the situation to eliminate all but one of the variables. And last but not least, use the chain rule to differentiate both sides with respect to t. So I hope that by watching this video, you had a better understanding about the application of differentiation about the related rates problems. So that's all from us. Thank you for watching, and Assalamualaikum.